much about this because of the fact that several of you aren't in this link. For those of you in the link, how'd the English class go last time? It was good? Yeah, because Tate's cool. I like Tate. So huh?
So he said he's a Laker fan.
I know. So that's why I pointed it out. Him and I have things going back and forth, so it's going to be a bit of a rivalry, but not everybody can be a Celtics fan. I understand. We had a lot of years of, oh crap, why am I a Celtics fan? We're back. Stupid like sorry.
Hey.
Hey.
That's bad language.
Huh? Stupid is but that's bad, man. My other words I use, I don't know. I'm straight to hell. So just to remind you guys, a few of the things we went over last time were the difference between inductive and deductive. I actually did an example just like one of the problems you have for homework that normally gives people the most trouble, which is that problem where they say, pick a number, do all this mess to it. Yeah, then part D says, prove it. And everybody always messes up, but what's the way you can prove something?
What's the number with something?
Yeah, start with the most general thing. Start with X. Or the book uses N for number, for natural number really, but you start with X, because X represents all numbers. So whenever you do something with X, you're actually doing that thing to an infinite number of things all at once. That is kind of mind-blowing, right? And that's why that's a proof. Doing a specific number just gives you an idea. Actually, I had somebody kind of excited to do that kind of trick to somebody else. And you guys can see, I mean, you can actually work it. You can make your own. You can actually say, how many TVs do you own? And say, okay, add that in. And then later you have them subtract the TVs so that overall it really doesn't matter about the TVs. You guys kind of see what I'm saying? You can actually work it out so that the number always comes out to their birthday or something. Oh my God. When you actually know the math, it's not a big deal, right? Okay. Look at this problem real quick. I want to show you one problem from the homework just to see if you guys can get the idea here. Maybe a couple problems. There's one problem that talks about square numbers. And I like it because it's very visual, for one thing. I think that's as far as I can take it. 9, and the next one, if you add several around the corner, you get 16 and so forth. So obviously square numbers, it kind of makes sense. What's the area of this square? It'd be 3 times 3, it's 9. 3 squared is 9. Right? So the next number would be 4 squared is 16. Blah, blah, blah. Right? 1, 2, 3, 4. Okay, there you go. And so forth. Right? Notice something really cool though. What's another? There's a whole other pattern here. Let me see if anything can come up. Except for the guy that I helped this morning. There's a whole other pattern here that you go between the numbers. Look, how do you get from there to there to there to there? Yeah, here you add 3. No, Jeff. 7. 5, 7, so forth, right? And so what's the next number up? It'd be plus 9, 25. That is the next square. That's kind of freaking cool, right? So for example, 12 squared is 144. And if you add 25 to that, you get 169. That's 13 squared, right? They're all separated by the next odd number. It's kind of cool. Okay. All right. So that's, that problem really just asks you what's the next few terms. You got a couple different ways to do it. Why would why would 71 not be a square number? What's a good way to answer that question? That's not the only reason, really, because 25 has an odd number on the end, and it's a square number, right?
It's not by itself.
What's the square number right below this one?
69.
64. What's the one above this one?
81.
And where are you getting those from? This is 8 squared, and that's
9 squared.
So can this be a square number?
No.
Because there's no whole number between 8 and 9, right? So that's one way to kind of approach that thing. Why wouldn't this do it? Because it doesn't match the pattern. It is not something squared. So you give me examples of things that are and say it's between those two. There's no way it can match, right? Okay, maybe. Okay. There's a whole section of just find the pattern, starting at number 19 through 28. And then I like 15 through 18. Those are visual find the patterns, right? Oh, let's see. Do we have a, oh, do you want the demo right there? Can you? Oh, I'm sorry. Brandy.
You weren't taking any directors, right?
Say again?
Are you taking any directors?
No, sorry. Missed out. Okay, cool. Beautiful. Okay, good. you see the little faces? You have to kind of tease out the pattern there, right? So it should be hopefully pretty straightforward. Just find the pattern. The other kind of problem is a counterexample problem, right? Sorry. Are you okay back there? Okay. Cool. Thank you. Okay. So there's one that says the sum of two odd numbers is an odd number. What would a counterexample of that be? This one's actually a pretty simple example. So how do you find a counterexample? What would you do? Okay. You have to find something that follows the first part of it, the sum of two odds, and show that the last part doesn't flow. Right? And actually this one's easy because the sum of any two odd numbers is actually an even number. So you can't help but find a counterexample. Right? But sometimes a counterexample is not very easy. For example, if I said divide any two whole numbers, the answer is going to be a whole number. Or let me say this, divide any two whole numbers, the answer is a real number. So if you do 8 divided by 2, that's 4. That's a real number. If you do 7 divided by 5, that's whatever it is. It's a real 1.4. It's a real number, right? There is one counterexample, though. So this, if I say the ratio of any two whole numbers is a real number, you can kind of go insane trying to find the counterexample. The problem is we're not using a specific freaky number that is a whole number. So I can do 8 divided by 2, that's 4, that's a nice whole number. I can do 9 divided by 8, that's whatever the hell it is, it's still a real number, right? But what can I divide by that'll throw this whole thing off, of course? It can't be negatives because whole numbers are starting at, it can't be decimals because whole numbers, right? Zero. So if I try to do 3 divided by 0, is that real? That's what we call what?
Undefined.
Undefined. Now, do you ever figure out, do you ever wonder why the hell do we call that undefined? I think most of you guys know we call it undefined. Some of you guys might know we actually sometimes call that infinite. And divide by very, very small numbers, don't I get a big number? So divide by nothing, I get everything basically. That's one way to look at it. I get infinite. But this is undefined. And a real quick side note here, the reason that is tell me, what is 6 divided by 2? 3. Why? Don't say because 2 goes into 6 3 times. Because 3 times 2 is 6. So the number that's defined to be what 6 divided by 2 is 3, because 3 times 2 is 6. But what's 6 divided by 0? It would have to be the number that when I multiply by 0, I get 6. Is there any number defined to do that? That's why we call it undefined. Right? So you shouldn't just let that go by. You should say, why the hell do you guys call it undefined? And the teacher should be able to tell you. Right? They better know why. Okay. But in this homework, it's not going to be quite as freaky as that. I want to give you that idea. Another one, I think the one that gave somebody some trouble was like the product of any two counting numbers is divisible by 2. So that could drive you a little insane. The product of any two counting numbers I'm really writing well today. Is divisible by 2. So your search for a counterexample, you do the first part of it and you try to show the last part is bogus. So if I start doing like 8 times 3, well that's 24, that's divisible by 2. Oh, let's do 7 times 4, that's 28, that's divisible by 2. And you start doing, oh man, what the hell? What could I try? What would be a good counterexample for this?
3 times 7.
3 times 3 or 9 times 3, you have to have both numbers be odd, because then neither number has a factor of 2. If I multiply two numbers that don't have a 2 in it, the whole thing doesn't have a 2 in it, right? Here, this 8 has a 2 in it, so of course the result has a 2 in it. You guys kind of see what I'm saying? So this is an example of how you might go a little insane if you're not careful trying to find a counterexample. You got to notice what numbers are you using and use different ones than what you've done. Not just different from 8 and 3, but that's even, that's odd. Or I haven't tried negatives yet. Or I haven't tried 0 yet. Right? So we haven't tried just pure odd numbers. That's not divisible by 2. There's my counterexample, right? That would be the answer. That's the counterexample. So like I was saying earlier, last time, it's easy to disprove something, or easier. Just gotta find something that goes against it. It's much harder to prove something.
Only one counterexample?
No, there's many.
Okay.
Yeah, so be careful. I don't want to see this in everybody's paper now, but you could do 9 times 3, you could do 5 times 5. As long as they're both odd, there you go.
On our homework, do you want like just the 8 times 3, 7 times 4, or do you want us to write out what the...
You don't have to write out what I just said. You really
just
just have
have
to
to
find a counterexample, but I'm kind of glad you said that. I need to see your work, right? So there's a problem like, if I gave a problem like 1, 5, 9, 13, what's the next one? Show me this. What is the pattern here?
4, add 4.
Show me add 4, add 4, add 4, add 4, and then now I can see where that came from. Don't just put the number down, right? The reason I do that is because, what did I say last time about sequences? That is one possible pattern. Sometimes I'll make a problem up, and there's a whole other pattern I didn't even think of. And if you just write a number down, I don't have a clue where the hell it came from. All I know is it's wrong from what I'm thinking. If you show me the work, I'm like, oh, cool, I didn't even think about that, right? But you have to show me the work. When in doubt, show me work. Okay. So any other specific things from that first section? And again, if you're having a lot of trouble accessing a book, just come see me in my office. I can try to possibly make a copy or something, as long as not 30 of you need that from me, right? Okay, cool. So what I want to do today is I want to keep going. I want to get into section 1, 2, and maybe into section 1, 3. Around 5 or 4:12 or so, we'll head out, so we can get to the Math Study Center about 12.